Hello, I'm Kyle. I'm the technical content developer at Maple Systems. Welcome to the Maple Systems video training series. In the previous video, we discussed the role that positioning plays in industrial automation as well as the communication setup using a Maple Systems PLC and HMI in the control and programming softwares MapleLogic and EB Pro. In part 2, we will be going over manual positioning as well as the basic and extended positioning parameters in MapleLogic. Lastly, we'll be demonstrating a live demo using manual control in ladder logic. Now, there are numerous ways for motor positioning to be programmed, from simple controls to complicated multi-step controls. This all depends on the controller you choose for your positioning project. The Maple Systems PLCs, modular and micro, have three main control functions: manual positioning, positioning instructions, and OPR control, or origin point return. Manual positioning allows users to generate a general pulse output to adjust positioning. This method is referred to as jogging or inching because the main function is to make small mechanical movements to reposition to the desired location, and we will be discussing positioning instruction and OPR control in later videos. Now let's go into MapleLogic and open up the positioning program. Now in the last video, we discussed that we'll only be using one axis in the sample project for simplicity. So we're only going to focus on the x-axis parameter. So here are the basic parameters, and then here are the extended parameters, and then here is the OPR parameters, which we will not be using until a later video. So first thing we're going to discuss is the start address. This sets the range of registers that will be used for the operation data, which can be accessed to monitor or control motor operations. So setting the start address to D0 will make the range D0 to D19 used for position control, and then the basic parameters here are used to set output pulse type and primary speed settings. Extended parameters are used for setting position limits, jog speed settings, and completion signals. And then OPR parameters, which we'll be getting into in a later video, are settings regarding the OPR control method, which is included for OPR method selection, OPR speed limits, and direction configuration. And of course, for more detailed information on all of this, you can refer to the help files in MapleLogic. You can also find the same information in the positioning user manual, which can be located on the Maple Systems website. Now, how do you monitor positioning? Well, there are two ways to monitor motor operations. The first way is to use the monitor window. So if you click monitor, now you'll be able to see this if you are online. So we're just going to look at it offline. So click no, and you'll be able to monitor your positioning here. And the other way is to monitor the registers using the device monitor. You can add the registers here under device. And again, you're not seeing any information here in the position programming monitor because you're not online with the PLC. In addition, all the positioning data can be accessed by monitoring the positioning addresses. So as I mentioned earlier, if you start the positioning program at D0, the x-axis will be D0 to D9. And the y-axis will be D10 to D19. This table here is used for manual control and monitoring of operations. Now, we'll be using the control registers in this example, specifically learning how to jog forward and backward using manual positioning. You can also find this same information in the positioning user manual, which can be found on the Maple Systems website. So we are going to be focusing on the control flag register to enable jogging on the x-axis because we are only using the x-axis. If our positioning program starts at D0, then by turning on D0.0 bit as well as the D0.3 bit, that will enable the forward jog command. If D0.3 is turned off and D0.4 is turned on, the backward jog will be enabled. Now let's move on to the Modbus addresses, which will be used to control the motor. In the previous video, we covered the Modbus communication setup between the Maple Systems PLC and the HMI. So here are the HMI Modbus addresses, and here are the PLC memory addresses. In this video, we will only be focused on the addresses for manual control, like D0 and Y100 and Y101 for jog forward and backward. The position control addresses will be used in a later video. Back in MapleLogic, let's take a look at the ladder logic for manual control. So using ladder logic to control the positioning of the stepper motor. As you can see, we're only using a few contacts, timers for delays, set bits, and reset bits to control the motor. This section here is a portion used to initiate forward and reverse jog or inching commands. So we are sending 1 to the D0 register to enable the X-axis before the timer triggers the forward or backward command. Then, once Y100 or Y101 are released, 1 is sent again to disable forward or backward jog commands, and then you can enable the X-axis again. Then you could send 0 to stop the jog as well as disable the axis. So for example, if you send 1 to the D0 word register, the bit 0 will turn on, which enables that axis, compared to if you sent, let's say, 9 to the word register, which would turn on the bit 0 and bit 3 and initiate the forward jog. So why 9? Because if you are using a program or calculator and enter in the binary 1 for bit 0 to enable the axis, then 0, 0, then 1 for bit 3, then the decimal equals 9. Let's go to the HMI project in Easy Builder Pro. Here is the motor positioning project. We will only be focusing on manual positioning in this video. So here are some momentary bits, which are assigned as 0x Modbus registers, so read and write. And in the PLC program, there are Y100 and Y101. And the rest you would also refer to the Modbus address table I mentioned earlier. So we also have some status flags, current speed, current position, and we will go over position control and position data instruction in later videos. Now back in MapleLogic, let's go online with our PLC. So go to online, link plus download plus monitor. Okay, here is our demo test kit. Here's the front panel, and you can see the HMI at the top, and below that is the stepper motor here, and then below that is the PLC and the I/O modules. So let's open up the kit and take a look inside. So first, off to the right is the power supply right here, and this powers all the devices in the kit. And then off to the top right is a Ethernet switch. The HMI right here and the PLC are connected to the switch so they can communicate with one another. Then below that is the stepper motor driver. Off to the left is the HMI, and then just below that is the stepper motor. And you'll be able to see the motor rotating on the front panel. And then below that is the PLC and its I/O modules. And so the PLC will send pulse train output signals to the stepper motor driver, and then the stepper motor driver will then output signals to the stepper motor, and then you will see the stepper motor rotating on the front panel. Okay, we are online and you're looking into MapleLogic. There's also some other windows here. On the top left is CMT viewer, so that is the actual HMI program. And off in the top right is the monitor window for our positioning. So you'll be able to see the motor going forward and backward, and also the pulses here and the current speed as well. And then in the bottom left corner is the ladder logic for the forward jog logic, reverse jog as well. And then in the bottom right corner is a live camera feed of the front panel of the test kit. So you can see the HMI, and you'll also see the stepper motor rotating in that camera view. I'm going to jog forward and jog backward on the HMI itself, so view the live camera feed to see that. So I'm going to jog forward. And you can see it here in the monitor window, it's running. And send forward, you can see the pulses here and the current speed. You could also see it here in the ladder logic. When the forward or backward jog buttons are released, it will then return to the enable axis state and the jog will stop. Now I'm going to go jog backwards here. You can see that reverse jog here in ladder logic, as well in the monitor window in CMT viewer. And that is positioning using manual control. In the next video, I'll be covering position control using the position control application instruction in ladder logic, also the position control parameters, and then the corresponding Modbus addresses. And then finally, I'll be showing a live demo with a stepper motor using position control. I hope you enjoyed this video, and thank you for watching.